Welcome to the Silicon Fox podcast, where we explore the habits and stories of high performers. Join us as we dive into their journeys, analyze live blood tests, and break down the science behind key biomarkers to help you optimize your health. I'm your host, Mitchell Eschner, an ex-pro soccer player, a current sponsored hybrid athlete, a health tech founder, and a longevity enthusiast. Today, we're focusing on ferritin, a biomarker that does much more than just store iron. Whether you're an athlete or someone curious about optimizing health, understanding ferritin will open your eyes to its profound impact on the body. Ferritin is often called the body's iron storage molecule, and while that's true, it's really only the tip of the iceberg. Ferritin is a protein complex that acts as a vault for iron, keeping it safe and readily available when needed. But ferritin's role goes far beyond just iron storage. It's deeply tied to immune function, inflammation, and cellular protection. This protein is found in almost every cell in the body, with the highest concentrations in tissues like the liver, spleen, and bone marrow, places where iron metabolism is most active. The liver is your body's main storage center for iron. The spleen acts as a recycling center for old blood cells, and bone marrow is where new red blood cells are produced. Small amounts of ferritin also circulate in the blood, and this circulating ferritin is where we measure in lab blood tests. You can think of ferritin as a hollow spherical protein. The shell-like protein is made up of 24 subunits. These subunits come in two forms. The first is called FTH, or the ferritin heavy chain, where enzymatic activity occurs iron into a safe, inert form, preventing damage to surrounding cells. The second is the FTL, ferritin light chain, which focuses on efficiently storing iron within the ferritin shell. The balance or ratio of FTH or FTL depends on the tissue and its needs. The ratio is like a fingerprint for what the ferritin molecule is doing and where it's located. A higher FTH ratio means this tissue is focusing on detoxifying reactive iron and protecting cells from the oxidative damage. A higher FTL ratio means the issue is focused on storing large amounts of iron for later use. For example, the liver and spleen tend to have more FTL to optimize storage, while the heart and kidneys have higher FTH levels for protecting against oxidative stress. Now let's talk about ferritin's relationship with iron. Iron is an essential mineral involved in oxygen transport, DNA synthesis, and energy production. However, free iron is highly reactive and can generate harmful molecules called free radicals. This is where ferritin steps in. Ferritin captures and stores iron safely within its shell, preventing damage. Each ferritin molecule can store up to 4,500 iron atoms. But here's where misconceptions arise. While ferritin is critical for iron storage, it's not solely about iron. One of ferritin's key roles is in immune regulation. Studies have shown that ferritin directly influences the activity of T and B lymphocytes, two essential components of the immune system. T lymphocytes, which help coordinate immune response and directly attack infected or abnormal cells, are sensitive to the levels of ferritin in the environment. Similarly, B lymphocytes, which are responsible for producing antibodies, can have their maturation and activity influenced by ferritin. By modulating these immune cells, ferritin helps maintain a balance between an effective immune response and the risk of overactivation, which could lead to harmful inflammation or autoimmune disorders. Another critical function of ferritin is the role in protecting cells from oxidative stress. The heavy chain subunit of ferritin, FTH, has a unique enzymatic activity that converts reactive iron into a stable, non-toxic form. This process is essential because free iron can catalyze the production of harmful molecules called free radicals through chemical reactions, like the Ferritin reaction. These free radicals can damage DNA proteins and cellular membranes, contributing to a range of diseases and aging processes. By safely sequestering iron and neutralizing its reactive potential, ferritin acts as a molecular shield, protecting cells from oxidative damage and maintaining their structural integrity. Ferritin is also involved in the cellular signaling. While its function is not as well as understood as its roles in iron storage and immune regulation, studies suggest that ferritin in particular in cellular communication, particularly under stress conditions. For example, during times of inflammation or oxidative stress, ferritin levels can change in response to signals from cytokines or other stress-related molecules. This dynamic response allows ferritin to serve as both a sensor and communicator, helping cells adapt to environmental changes and coordinate their activities to protect the body. One of ferritin's most fascinating roles is to respond to inflammation. When the body detects an infection or injury, inflammatory cytokines like IL-1B and TNF-A signal cells to increase ferritin production. Well, why? Because ferritin helps limit the availability of iron to pathogens, starving them of a critical resource. At the same time, ferritin protects tissues by capturing iron and preventing oxidative damage. This dual role makes ferritin a hero in the short term. However, chronic inflammation can cause ferritin levels to stay elevated, leading to complications. Now, let's talk a little bit about ferritin levels and what they mean. Ferritin levels in the body, much like many aspects of health, operate on a Goldilocks principle. You need them to be just right. Levels that are too high or too low can indicate significant underlying issues, making ferritin an essential biomarker for understanding the body's overall health, particularly in relation to iron balance and inflammation. When ferritin levels are too low, several symptoms may arise. Individuals with low ferritin often experience fatigue, weakness, and shortness of breath. These symptoms occur because, as we know, ferritin is closely tied to the body's iron reserves, which are critical for producing hemoglobin, the molecule responsible for transporting oxygen throughout the body. Without sufficient ferritin, the body's oxygen transport system falters, leading to decreased energy levels and impaired physical performance. Another symptom of low ferritin is poor thermoregulation, which can lead to individuals leaving unusually cold, unable to adapt to temperature changes. The causes of low ferritin are typically rooted in iron deficiency. This can result from a variety of conditions, such as heavy menstrual bleeding, which depletes iron stores over time. Poor dietary intake of iron-rich foods like red meat, beans, or leafy greens is another common cause. Malabsorption syndromes, such as celiac disease or Crohn's disease, can also prevent the body from absorbing iron efficiently, even if dietary intake is inadequate. Each of these causes depletes the iron reserves stored in ferritin, leaving the body vulnerable to energy deficits and reduced oxygen delivery. Now, on the other hand, high ferritin levels can also signal trouble. Individuals with elevated ferritin may experience joint pain, fatigue, and liver damage, with severe cases even leading to organ dysfunction. These symptoms arise because ferritin overloaded is often a sign of iron toxicity. Over time, this oxidative stress contributes to chronic conditions, worsening inflammation and damaging vital organs. The causes of elevated ferritin levels are often linked to chronic diseases such as liver disease or systematic inflammatory conditions, which stimulate excess ferritin production as part of the body's inflammatory response. Elevated ferritin has also been associated with metabolic syndrome, cardiovascular disease, and certain cancers, further understanding the importance of maintaining a healthy balance. Understanding ferritin levels can offer valuable insights into both short-term and long-term health risks, guiding interventions to restore balance and protect the body from the harm. One study from the University of Cambridge dug into whether iron, particularly as indicated by serum ferritin, can be a secret to enhance athletic performance, or just misunderstood component of our training physiology. The research aimed to examine adaptive changes in iron metabolism during exercise, assesses whether iron supplementation benefits athletes, and uncovered the potential risks associated with indiscriminate iron usage. Their work provides insights into how the body manages iron under the intense physical demands of sports, highlighting both the benefits and dangers of supplementation. The study wasn't a simple clinical trial, but was a comprehensive review of existing data. It synthesized decades of research on how exercise-induced physiological changes mimic signs of iron deficiency, like lower ferritin and hemoglobin levels, leading to many athletes to supplement iron. They also examined biomarkers such as soluble transfer receptor protein and bone marrow iron to distinguish true iron deficiency from exercise-induced changes. Key focus areas included changes in blood parameters during training, such as sports anemia, a temporary drop in hemoglobin during early training phases, and the risk of iron overload, particularly in genetically predisposed individuals, and its implications for liver health and metabolic conditions like diabetes. Here are the findings and insights. First, the case of iron deficiency versus adaptation. The study found that while serum ferritin levels often drop during training, this doesn't necessarily indicate true iron deficiency. Instead, it's an adaptive response to increased plasma volume and changes in erythropoiesis, our body's red blood cell production system. Second, there are limited benefits to supplementation. For athletes without anemia, iron supplementation offered little to no performance improvement. However, in iron-deficient individuals, targeted supplementation improved endurance and VO2 max, critical metrics for performance. The study also found risks of oversupplementation. Uncontrolled iron supplementation posed significant risks, including hemochromatosis, a condition leading to iron overload. Excess iron also obscured signs of serious underlying conditions, like gastrointestinal bleeding or celiac disease. And finally, there were gender and age factors. Female athletes and adolescents were at higher risk of iron deficiency due to menstrual losses and rapid growth, emphasizing the need for tailored dietary and medical approaches. The study reminds us is that more isn't always better. Athletes should keep three things in mind. 1, routine testing for ferritin and other related markers, like STFR, is crucial to discern true deficiency from exercise-induced changes. 2 is that supplementation should be reserved for cases of confirmed iron deficiency anemia and monitored closely. And 3, dietary strategies emphasizing iron-rich foods like red meat, leafy greens, and fortified cereals should be the first line of defense against deficiency. Understanding ferritin and iron deficiency isn't just for athletes. It's for anyone striving to optimize health. Low ferritin can signify deficiencies that impact energy, immune function, and even cognitive performance. Oversupplementation, that's a different kind of danger altogether, leading to oxidative stress and organ damage. So before you reach for an iron pill, consider taking your ferritin levels and getting them checked. And if you're just an athlete, remember, the goal isn't just to train harder, but to train smarter, understanding the science behind your body's needs. Ferritin is more than just a biomarker. It offers practical applications for optimizing health and understanding the body's internal state. By examining ferritin levels, we can gain valuable insights into iron storage, inflammation, and the overall balance of metabolic and immune process. These applications extend across everyday health, management, athletic performance, and clinical research. For everyday health, ferritin testing is an accessible and informative tool. A simple blood test can reveal a wealth of information about your iron status and inflammation levels. So the next time you glance at your lab results, remember that ferritin is telling you a story about your body's past, present, and future. Thank you for tuning in today. I hope you've gained some insights into this biomarker. If you found this episode helpful, be sure to subscribe and share it with others who might benefit. And as always, I encourage you to take charge of your health by staying informed and being proactive about your body's signals. Thank you, and we'll see you next time on the SciFox Health Podcast.